So let's begin. Abstraction is the term, is what we call when we ignore implementation details that we're not concerned about. And that's a pretty vague definition, so I'll kind of help clarify it. If, say, let's think of an example. Let's say you're texting your friend. So let's say this is you and this is your friend. Now, as you're texting your friend, all you're concerned about is that the text that you send, whatever you write and then you hit send, that is what your friend gets, nothing else, nothing less, nothing more. So that's all you're concerned about. Now imagine that you had to be concerned about how the phone is converting your text into data, into binary, how it's encrypting that, encoding that, whatever it's doing, how then WhatsApp or whatever messaging client you're using is sending that to its servers, yada yada, and then finally it reaches your friend's phone and he reads it in English or whatever language you sent it in. Now, if we had to worry about all those details, messaging would be a lot less convenient than it is, right? But the fun thing about that is we don't. We don't need to worry about binary, programming, encoding, decrypting, encrypting. And that's because all of these details have been abstracted away. They have been abstracted away from us, and we don't need to worry about how they're being implemented, how a message is being sent or received. And that is essentially what abstraction enables us to do. And let's take a more computer science-y example now. I'm just gonna move these out of the way. Let's say you had to make a program for a classroom, and in it you were doing a bunch of stuff. You were calculating class averages, getting grades from students, from teachers, whatnot. And so since this is a lot of work, you ask your friend to write you a function. For those of you who don't know, a function is basically a small piece of code, and it's reusable, and basically it's something that can be used again and again. You can just call it by its name. For example, the function's name here is display grades, and you'll learn more about these in the future in much more detail. But let's say your friend built you this function, he wrote all the code for it, and he gave it to you. Now, since what he has basically done for us is, now that he has written the code and hidden it away basically inside a function, we don't need to worry about how he wrote that code, because once we start worrying about how he implemented all those all those procedures, all those ways to calculate and display grades and whatnot, then we're basically undoing whatever he's done. And so to be able to actually benefit from his abstracting away all these details, we need to just take this function and use it. And so that's basically what abstraction is. It's when we simplify the model of what we're working with, and we focus on the details that we're concerned with right now. So for example, in this case, we would be concerned with the fact that when we call this function, when this code actually runs, the grades are displayed as expected. As long as that happens, we don't care how it happens, what code it is run on, we don't care about any of that. We just care that it happens. So that's what abstraction is. Now, you might already be thinking of some advantages of this. Some benefits might already be clear, but I'll just make them more clear. So why would you abstract something? Why would you even use abstraction? One, in software development, when you abstract the details away, it leads to a reduction in development time, because now you don't have to worry about a lot of the details. So similar to this example right here, if you use a reusable piece of code that's, like, for example, in this case our friend made it for us, but imagine it existed before we started even writing our code, and we just reuse that in our program in order to abstract away the details of that implementation, like that implementation of that part of the code, then we need to worry about less stuff, and hence we can develop that program, that software, faster. So that's one reason. A second reason is that our solution is more relevant to the given problem if we abstract away the details. So if we focus on only the details that the task revolves around, then we can build a more task-centric or problem-centric solution, instead of just branching out in all directions and doing stuff we don't really need to do and dealing with details we don't need to deal with. So that's another advantage. And a third advantage is that it's a more minor advantage, but it's an advantage nonetheless, is that when we don't care about so much of the details, we don't really mess with details on that meticulous low level, then we can build a program that is smaller in size, because we're only caring about and we're only working with the bare minimum amount of details that we need to work with. So yeah, it'll take up less space in memory, it'll be easier to maintain, use, etc. So that is basically what abstraction is. Its benefit, how it's implemented, and how you would basically use it, and its benefits. So yeah, thank you.